Okay, in these videos, or in this video, we're going to talk about analyzing each equation that we have here. And we're going to identify the topic conic section, as well as the key features, the vertices, the foci, the center, the asymptotes, directrix, depending on what we have. So a lot of times the easiest thing is to identify the conic section based on the equation type and where our center is. All right, so for this first one, we have x squared and y squared with addition. So this is going to be an ellipse, right? And we know that we're going to have our center, right? Our center is going to be at the point x negative 5, y 0. Okay? For b, we have x squared minus a y squared. So we know that this is going to be a hyperbola. All right. And I know that for this one, my center is going to be x0, y3. All right. If I look to my next, I have y squared, but not x squared. So I know I'm going to have a parabola here. All right. And this parabola, we don't have a center, but we do have a vertex that we talk about. And the vertex would be with an x coordinate of 1 and a y coordinate of 2. Okay? And the last one, well, we don't have, right, we don't have a standard form of our equation, but note that 13 times 36 is equal to 468. That if we take 13 and multiply it by 36, we get 468. So if we divide each term by 468, if we divide each term by 468, what we're going to end up with, is an equation that is x squared over 36 plus y squared over 13 is equal to 1, which tells us we're going to have an ellipse. And I know that the center is going to be the origin at 0, 0. So a lot of times that's the easiest things to identify first. Okay. Now we're going to come back up and let's identify other key features here, right? Other key features for the ellipse, right? We can identify the value for A, and that's going to be 4 because the square root of 16 is the larger number. We can also identify B, and that's going to be 3, right? So 4 is going to be my semi-major axis, and B is going to be my semi-minor axis. And I know the relationship B squared is equal to A squared minus C squared. So that means that 9 is going to be equal to 16 minus C squared. So that would tell us that C is going to have to be, well, let's see, 16 minus what number gets me 9? And that would be 16 minus 7. So C is going to have to be the square root of 7. Now, for a hyperbola, our value for A is not necessarily the larger number. Our value for A is the number that is in front. And in that case, our value for A would be equal to 3. All right. And our value for B is going to be the value after the subtraction in the denominator when I take the square root. So B is going to be equal to 4. And C, we can find by the relationship A squared plus B squared is equal to C squared. And so A squared plus B squared is equal to C squared will tell us that C is going to be equal to 5. That's for our hyperbola. Okay. Now, for our parabola, we know that we have our general form of the equation, that we have a 4p x minus h, right, and y minus k squared, right? So that would tell us then this value for p is going to be equal to -3, and we know that that is going to be the distance from the vertex to the directrix or from the vertex to the focus. We know that we'll have a distance of 3 units from the vertex to either the directrix or the focus, but the negative is going to tell us that we're either going to open to the left or we're going to open up. or excuse me, open to the left or open down. Okay. And over here for our ellipse, on this side, a is going to be the square root of the larger number, and so that square root is going to be 6. B is going to be the square root of the smaller number, and so that's going to be the square root of 13. And we know that for an ellipse, the relationship is b squared equals a squared minus c squared. And if I calculate that, that means that, all right, 13 is going to be equal to 36 minus some number, right? And so if we rearrange, right, 36 minus 13 is going to be 23, right? So we know that 13 is equal to 36 minus 23, which will tell us that c is going to be the square root of 23. Now, with that information, we'll be able to draw our graphs. So we can come back up, we can say, okay, well, what are our graphs going to look like? Okay. Well, for this first one, what we'll have is we know we have an ellipse, we know where the center is, we know the semi-major axis, we know the semi-minor axis. So we could come over and say, okay, well, I know where my center is at -5, 0. So I'm just going to go ahead and say, here is going to be my center. And I'm going to say that that is, right, my center. And I'll just go ahead and call it C to make it easier, right? That is going to be my center, and it's going to be C. Right, now my semi-major axis is going to lie along the y, and so I'm going to go 4 units up, 1, 2, 3, 4, right, and I'm going to go 4 units down, 1, 2, 3, 4, right. So that's going to be my distance from a vertex at my top and from a vertex at my bottom. Right, so I'll say vertex 1, and I'll say vertex 2. I also have my semi-minor axis of 3, so I'm going to go 1, 2, 3 units to the right, and 1, 2, right, and 3 units will be over here to the left. And I know that I'll call this over here vertex 3, and I'll call this over here vertex 4, right? And I'm going to have my ellipse. I need to draw in my ellipse, so I'm just going to kind of set this in, right? So I've got my ellipse. I also know that I'm going to have foci. I also know they're going to have foci. And the foci has a distance from the center of root 7. Right? So I'm going to say that, hey, I'm going to have, right, focus 1, right, above the center, and I'm going to have focus 2 below the center. Right? Now I'm just going to go ahead and write out my values. Right? So I've got vertex 1, I've got vertex 2, I've got vertex 3, and I've got vertex 4. Right? And I already referred to my center, and I also have focus 1, and I also have focus 2. So vertex 1, for vertex 1, the x-coordinate is -5, and the y-coordinate is 4 values above my y-coordinate, so that would be 5, 4, while vertex 2 would be -5, -4. Right? For vertex 3 on the right, I know that the y-coordinate is going to be 0, and for vertex 4, I know that the y-coordinate is going to be 0. But for the x-coordinate, I'm going to be 3 units to the right of -5 for vertex 3, and 3 units to the left of -5 for vertex 4. All right, so I have my major axis vertices 1 and 2, and my minor axes vertices 3 and 4. For the foci, I know I have a distance c from the center. Right, I have a distance c from the center, and I will have then, and let's label this as a C1 so we can distinguish, right, that that'll be C1, the center, right? So F1, the focus above the center is going to have an x value of -5 and a y value of root 7, while focus 2 will be -5 and a y value of negative root 7. So that's going to be what I have for my first ellipse, right? And that identified the vertices, the foci, and the center. No asymptotes, no directrix. Okay. If I look at D, which is also an ellipse, I have a center of 0. I have a center of 0. So for my ellipse at the origin, I'm just going to say that, hey, here is my origin, right? I'm going to say that's C1, my center. Okay. Now, my A value is underneath my X, so I know I'm going to be along the x-axis, or along the horizontal rather, for my major axis. And I'm going to be, let's say, 1, 2, 3, 4, 5, 6 units to the right, and 1, 2, 3, 4, 5, 6 units to the left. Right? Now, for the y-axis, I'm going to be root 13 units above and root 13 units below. So I'm going to say 1, 2, 3, right? We'll say root 13 is there. 1, 2, 3, and we'll say root 13 is over there, right? So I'm going to go ahead and say vertex 1, vertex 2, vertex 3, vertex 4. I'm going to be clear in my labeling. Right? So I've got my different vertices. And I'm going to come in and I'm just going to draw as best I can, right, an ellipse. So I have my center, I have my vertices. And I know my foci as well. My foci, root 23, so not quite 5, So I'll say I'll have a focus to the left of my center because I'm aligned horizontally, and I'll have a focus to the right of my center, and I'll call that focus 1, and I'll call that focus 2. So now I have a general form of my ellipse, right? So for my vertices, maybe I label them right over here since I already have the thing set up. So for my center, vertex 3 is above it, and it's going to be root 13 above, so that'll be 0, root 13. Right, and for vertex 4, x value 0, y value negative root 13. Right, for vertex 1, a distance of 6 away, so that's 6 and 0. And for vertex 2, the same thing, a distance of 6 away, so that's negative 6 and 0. Right? And I seem to have space inside to be able to write my foci. And so my foci, I know the distance from the center is C. So for my foci, I would say negative root 23 comma 0 on the left, and I would have root 23 comma 0 on the right. So that gets my ellipses done. Now let's have a look at my hyperbola. Okay. And for the hyperbola, I know where my center is. My center is at 0, 3. So I'm just going to come over here. I'm going to say, okay, so here is my center, right? And we'll say C1. We'll label that C1. All right. Now, for my hyperbola, in the x direction, I need to move 3 units. So 1, 2, 3. And that is going to be a vertex, right? And then 1, 2, 3 in the other direction, I'm going to have a vertex there as well. All right, so I'll say that this is vertex 1. I'll say that that is vertex 2. Now, I also want to identify moving up 1, 2, 3, 4, all right, and moving down 1, 2, 3, 4 to create my box, right, to create my box that I will be able to use to draw my asymptotes. Right? I'll be able to use this to draw my asymptotes, right? So I'll come over and let me change that color, and I know that I'll have an asymptote, right, that follows along that corner of the box, an asymptote that follows along, right, the other corner of the box. And it doesn't have to be beautiful, but should be close. Then I can come over, I can say, okay, well, I know that my hyperbola is going to follow along those asymptotes. I know that my hyperbola is going to follow along those asymptotes. So there I have my hyperbola. Okay, so I have my vertices, I have my center. I need to be able to give my equation of my asymptotes, right? So for the equation for my asymptotes, and I might write this off to the side here, I'll say, hey, my asymptotes, all right? I'll need to be able to get the equation for the asymptotes, which I know is going to have my y minus, right, my center y, which is 3, is equal to, right, my slope. So I'm going to have plus or minus whatever my slope is times x, and then minus, right, in parentheses over here, right, for my x value would be x minus 0. Now, what's my slope going to be? Well, I know that the distance there is 4. I know that the distance there is 3. So my slope is going to be 4/3. So y minus 3 equals plus or minus 4/3 x minus 0. So I've identified my vertices, but I still have to identify their coordinates. I've identified my asymptotes. I've identified my center, but I haven't identified my foci. So I need to identify my foci for this. So for my foci, I know the distance from the center, right, out to my focus. I know that that distance is going to be my focus. That distance from the center to the focus will be C. And I'll have the same on the other side. We'll say there is F1, right? So I know that I have vertex 1, a distance of 3 units away from the center. So vertex 1 would be x3, y3. And vertex 2 would be negative 3, y3. Right? And for my foci, I might say, hey, I can write it down here, that for focus 2, I'm going to be 5 units to the left of my center, so that's negative 5, comma 3. And focus 1, I'm going to be 5 units to the right. So that's going to be positive 5, comma 3. So now I have all the information for my hyperbola. Okay. Then I've got my parabola as my last one left to do, right? So for my parabola, I know the information that I need to label, right? So for my parabola, I can come over and I can say, okay, so I need to label the information for my parabola. I have a vertex of 1, 2. So I'm just going to come over here and I'm going to say, hey, here's my vertex, right? And I'll call that V1 to be my vertex. Okay, now I know I have y squared and x not squared. So what that tells me is that I'm going to be opening to the left or opening to the right because I have a negative p-value and I'm going to open to the left. And that p-value is negative 3. So I know that over here will be my focus, and 3 units on the other side will be my directrix. All right, so my directrix would be an equation x equals because it's vertical. And I know that my parabola will open, right, and be symmetrical over that focus. So I have the general shape. Now, what are the coordinates of the focus? Well, for the focus, I was 3 units to the left. So that's going to be negative 2, comma 2. And for my directrix, it's going to be 3 units to the right. So that's going to be x equals 4. Now, there is no center for a parabola. There are no asymptotes for a parabola, but I've got all the other information clearly identified. So those are the things that we want to be able to identify when working with parabolas, hyperbolas, ellipses, which are 3 of our conic sections.